So June 2021, Unit 6, we'll discuss some questions from this unit. In the first question, you can see the time period of a rotating wheel can be determined by using an apparatus shown. A magnet is there, a coil is attached, and it is connected to an oscilloscope. Actually, what happened when this magnet will rotate, there will be a change in a magnetic field that induces an EMF in the coil. And when magnet will return back again at the same position, again there will be a peak. So the distance between the two peaks will be equals to the time period. The magnet is attached to the edge of the wheel, and when the magnet passes the coil, a single pulse is displayed. You can see here. The horizontal axis for oscilloscope is representing the time. The number of millisecond per division, like how many milliseconds are there in one box equals to how many milliseconds. As a wheel rotates, the series of pulses displayed. Describe how a value of a time period could be determined from these pulses. So if we want to determine the time period, what we have to do, we have to first count the number of the boxes between the two successive pulses, because time period is a time, because say this is a wheel, a magnet is there, and this one is a coil. So when the wheel is rotating, when the magnet reaches this position, there will be a peak. And then magnet return back to the same position, there will be another peak. So the time interval is the distance between the two peaks. So we'll measure the distance between, or count the number of the boxes or number of division between the two peaks and multiplied by the value for each peak. We don't have to show how much it is. So first we have to count the number of the boxes between the two peaks, successive peaks, and then multiply by the division. Like they mentioned that one division is representing 1 millisecond. As it is mentioned here. So you just have to mention, like measure the number of the boxes between the two successive peaks and multiplied by the number of the division, like one division equivalent to how many milliseconds. When the wheel is tested, the speed of a magnet is 22.2 meter per second. The oscilloscope can be adjusted to give the following values: 1, 2, 5, and 10 millisecond per division. Explain which of these scales would display two complete pulses on the screen, and the wheel diameter is 25.4. So we get that speed is given to us. When the wheel is the speed of a magnet is, this is speed is given, V is given, and diameter D is given. So we can just work out the time period, and then we can identify which scale is listed. So we have the formula V equals R omega. And omega, whenever there's a complete rotation, omega is equals to 2 pi divided by T. So if we need T, so T will be equals to 2 pi divided by omega. So first we'll work out omega. So V is given 22.2. R is a radius, this is a diameter of the wheel is given, so radius will be half of a diameter. So 25.4 divided by 2, that will be the radius. Radius is half of diameter. So we divide, we get the radius here. But that is in centimeter. We have to convert into meter. So we have to divide it by 100. So this will be, the radius will be 25.4 divided by 2, because diameter convert, and then the value to convert into meter divided by 100. And this will give us the value for omega. So this, when we simplify this, the value of omega will be 175 radians per second. That is omega. Now we need the time period. So T is equals to 2 into 3.14 divided by the omega, which is 175. So we get the value for T, which is 35.9 into 10 to the power minus 3 seconds, or we can say 35.9 millisecond. So this is a time period. So which setting, like we worked out the time period now, which is 35.9 millisecond. So if we check, as you can see here, like this time interval is how much? 35.9. This time interval is how much? 35.9. Because that we worked out as a time period. So what setting we should use for the screen? Different settings are there. And one division is actually representing one box. Like one division is equals to width of this one box is equals to, from this point to this point, this is one division to, so when we check for this one, starting from here, and so this is like 5. If we take different divisions, we can take. So milliseconds per division, like it can be 1 millisecond, it can be 2 millisecond, it can be 5 millisecond per division, or it can be 10 millisecond per division. So what division we can take as the time period we worked out from here to here, it is 35.9. And how many boxes are there? This is one box, two box, 3 and 3.5, about 3.5. So means 35.4 divided by 3.5. So we get approximately 10 divisions. So means the scale which is used here is about 10 division per, like 10 millisecond per division. Like one box, the width of one box is actually equals to 10 millisecond. Is it clear, this one? That how we worked out the scale? 2, 5, sorry. So first we work out the time period, and from that time period we worked out what is the distance between the two successive peaks. So distance between the two successive peaks is about 35.9. So then we counted how many boxes are used here, 1, 2, 3, and about 3.5. So divided by 3.5. So it is about 10. More than 10, but we say it's about 10. So means it is 10 milliseconds. Like one box is approximately representing 10 milliseconds. Moving on to question 2. The specific latent heat of vaporization of a water can be determined by using an apparatus as shown. A heat-proof apparatus is there, a 12-volt DC heater. Devise a plan to determine the value of a latent heat using a graphical method. You should include a circuit and additional apparatus required. The latent heat is how much energy we need to change the state. So energy for 1 kilogram object without changing temperature. So latent heat is energy divided by mass. Practically, the energy which we supply, we use heater, so it is power into time divided by mass. And P is equals power. If we know, sometime it is listed on the device Sometimes we have to work out the power by using a product of voltage and current. So VIT divided by M. And we have to use the graphical method, means we have to select two variables that will change and we work out according to the like using a gradient to work out the latent heat. So if we rearrange this equation, the equation will be ML is equals to VIT, or because we have the equation y is equals to mx plus c, so I can also write like quantity on a y-axis should be separated from others. So m over VIT divided by L. Now, if we compare with the equation of straight line, y is equals to mx. On y-axis, if we plot the mass, kg. On x-axis, any of the quantity you can take. You can take voltage, you can take current, you can take time. Any of these quantities. For example, if I'm taking time on x-axis, so time will be there on x-axis. There will be no y-intercept. So what will the gradient? The gradient will be equals to Vi over L. And if I need a latent heat, so latent heat is Vi divided by gradient. That's how we work out. And the circuit, the electrical circuit which we need, DC heater is there. So we need a voltmeter to measure the voltage. We need an ammeter to measure the current, and then the supply. And what are the points you will mention? Because here we are plotting a graph between mass and time. So first we'll measure the mass, and the additional apparatus which we can mention is stopwatch, ammeter, balance is already there. So stopwatch we can mention, and ammeter and voltmeter also we can mention that. So first we'll measure the mass as we are determining the latent, and we switch on the heater until the liquid start to boil. When the liquid start to boil, we record the time and record the time for all the liquid to boil off. And then use a voltmeter and ammeter readings to measure voltage and current. Then repeat the experiment with like 5 different masses or 8 different masses or 7 different masses. And plot a graph between mass on y-axis and time on x-axis. Find the gradient. Then voltage into current divided by the gradient will give us the latent heat of this object. So planning experiment is important, like it's a 6-mark question. Then one significant source of error in this experiment was uncertainty in the mass due to the water moving as it boils. How other significant sources of error affects the latent heat? So one source of error, because as we are boiling the water, it will produce a convection current, and that convection current can cause a change in the mass continuously. Other thing which are leads to a sources of error like heat loss to the surrounding or heat gain from the, usually it's a hot object, so heat loss to the surrounding. And if we have a heat loss to the surrounding, we have the formula latent heat is VIT divided by M. So if heat loss to the surrounding, we have to heat for a longer time. If we have to heat for a longer time, then the mass will be, then the latent heat will be too large. Voltage and current won't change. A significant source of error, like it will not cost too much. So the point which you have to relate here, why it's of 3 marks. 1 mark you will mention heat lost to the surrounding. If heat lost to the surrounding, we have to heat for a longer period of a time. As a result, the latent heat will also increase.